Myself, M. Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions in the Department of Civil Engineering. I am going to discuss about foundation engineering subject. We are going to discuss about pile foundations in Unit 5. In the last lecture, we started with various aspects of pile foundations. First, pile foundations and why it is required. We have discussed that when the above soil strata is not good or poor in nature, that is unable to take the load which is coming from the superstructure, then we need to extend the foundation to the larger stratum, and those types of foundations, they are called as deep foundations, and pile foundations is one of the type. And then we discussed that what are the various types of pile foundation depending upon the load transferring mechanism. Piles can be classified as point bearing pile, skin friction, then compaction pile, tension pile, construction of pile. These can be classified as timber piles. Then we had steel piles, and then we started with concrete piles. In concrete piles, there were two types of piles. One was board cast in situ, and another was driven precast concrete pile. So we saw that what are the main features of this pile in the last class. Today let us try to discuss about what are the disadvantages and advantages of these two types of concrete piles. How one can be superior to another, or what exactly is the advantage or disadvantage of one particular type to the another one. We are going to compare advantages and disadvantages also. First, starting with advantages of driven cast in situ piles. Once again, I would like to recapitulate that what are these words mean by driven is that if you are driving it by any mechanical means, by hammering or by vibration, cast in situ, it is getting casted at the site itself. They can be driven to a predetermined set. Pile lengths are easily adjustable. Since they are being casted at the site itself, so let us say that at the 11th you can change the length of the pile, then that can be taken care of, and an enlarged base can be formed, which will help in generating much higher end bearing capacity in a granular bearing stratum. Let us say that you are driving a pile in a granular bearing stratum, and then towards the end of the pile, that is where the tip will be resting, there you can provide an enlarged base which will result into larger bearing capacity. This aspect also we discussed in the previous class. In this case, reinforcement is not needed to take care of handling or driving stresses piles. Stresses piles can be driven with a closed end. So as to exclude the effect of groundwater, let us say that while driving the pile, you come across somewhere groundwater table. So if the pile is driven with closed end, there you will not be having any effect of this presence of groundwater table. Some of the disadvantages of driven cast in situ piles, that heave of adjoining ground surface which could not affect the surfaces of structures or nearby structures. That is, let us say a very sophisticated structure is there in a nearby location, that does not mean you have to protect that from any kind of vibration. So in that case, while driving the pile, there will be a lot of vibration due to hammering which will be taking place, and the heave also can occur. So that is one of the disadvantage of driven cast in situ piles. Lifting of previously driven piles where stratum has not been sufficient, so that is again one of the disadvantages. Possible damage to uncased piles by necking or wasting due to lateral forces. When the concrete is green, let us say that concreting is going on and the concrete is green, in that particular case. And in case of uncased pile, when after concreting you are not taking out the casing type of pile is uncased pile, so possible damage can be there. Then concrete cannot be inspected after the completion of work. Concrete may be weakened if artesian flow pipes up the shaft of pile when the tube is withdrawn. Again, this is when the concrete is weakened, obviously the pile bearing capacity will decrease. So that is not desirable. So it becomes one of the disadvantages of driven cast in situ piles. It cannot be driven where headroom is limited of driven cast in situ piles. It cannot be driven when the headroom is limited. Then the limitation in length because of lifting force required to withdraw the casing. So let us say in case of uncased pile, you have to take out the casing. So in case of higher length of the pile, the lifting up of the driven cast in situ pile, the maximum pile length which you can go for in case of driven cast in situ pile is of the order of 25 to 30 meters, and allowable load which any driven cast in situ pile can take depending on the soil condition can be of the order of 1500 kilonewton. Now some of the advantages of bored cast in situ piles. What do we mean by bored? What means that you have to first create a void by boring or some excavation measure, and then you have to fill that with the concrete, which will form as a bored cast in situ pile. It is getting casted at the site only. Very little displacement or no risk of ground heave, as you know that this falls under the category of non-displacement piles. So in this case, there is no mechanical hammering which is taking place while driving the kind of pile. So very little displacement is there and there is no risk of ground heave at all. And length can be readily varied. Soil can be inspected and checked with soil investigation data. See, when you will be creating the void or excavation, so whatever is the soil that you are taking it out, you know at which particular depth you are taking that soil out by examining that particular soil, and by comparing with the soil exploration data, it gives you to check whether your soil exploration data is proper or not. It just confirms that information. Piles can be installed in very great lengths and very large diameter. That is one of the main advantages of bored cast in situ piles. End enlargements of up to 2 to 3 shaft diameter are possible in clay or soft rocks. In the earlier case, we have seen that it was for driven cast in situ pile. It was the enlarged base was able to form in the granular deposit. However, in case of bored cast in situ pile, this end enlargement can be possible in clays or soft rocks. It can be installed without much noise and vibration with limited headroom. Now, some of the disadvantages of bored cast in situ piles are that boring methods may loosen sandy or gravelly soil. See, if the soil is of the clay in nature, then this bored case of sandy or gravelly soils in the process of boring or excavation or creating the void, there can be loosening of the soil strata, which is not at all desirable as far as construction is concerned. Concreting under water will pose problem. Why? And then you are filling up that with concrete. So in case if the water is present somewhere along the length of the pile, that can pose the problem. Then concrete cannot be subsequently inspected. Once you have created the bowl of, let us say, 30-meter depth, then you have to go on pouring the concrete, then go on compacting it. But we really cannot inspect that to what extent it was got compacted, whether we have achieved the desired degree of compaction of concrete or not. So that becomes one of the disadvantages of this kind of piles. Now these are susceptible to wasting or necking in squeezing ground. Enlarged bases cannot be formed in case of granular soil. In case of clay soils, you can do that, but in case of granular